In part 3 of our introduction to functional groups, we're going to talk about compounds that no longer just have carbons and hydrogens in them, but they also have a single bond to a heteroatom. All right, so when we talk about compounds that have a single bond to a heteroatom, we're saying that it's anything besides carbon and hydrogen. So our first example are alcohols. Alcohols have a hydroxyl group, which is an oxygen bonded to a hydrogen. So the general structure for this, we can have a carbon chain of any length, which is our R group, and it would be attached to the oxygen. Remember that oxygen has 2 lone pairs of electrons, which is why it doesn't make any more bonds than the single bond to the R group and the hydrogen. An example of this in an actual structure, we'll use a 2-carbon structure. This would be ethanol, and we'll talk about how to name these later. But you would see an OH group coming off. It can be attached either on the end of a condensed structural formula, or we can attach it with a line, and we will get into all of this very soon. Alkyl halides are compounds that have a carbon chain with them, but then they also have a halogen atom attached. The general structure is a carbon chain of any length, which is what we give our R group designation, and it's attached to a halogen, which is denoted by X. And frankly, that can be a little confusing, so let's see an example where we actually put a halogen with a carbon chain. So we'll use the same amount of carbons as before. We'll use our 2-carbon chain. Notice that I'm putting enough hydrogens on here that will complete octets for us. And I'm going to add a fluorine, which is my halogen of choice today, to this. So anytime you would see this halogen on there, you would consider this to be an alkyl halide. And going back up, this is my functional group that I'm looking for. Anytime I see an OH, I would designate that as being part of the alcohol family. All right, moving on. Ethers are single oxygens. Ethers are going to be in the middle of a chain. So I'll have a certain number of carbons that are bonded to an oxygen followed by a certain number of carbons. So I like to think of these guys as being sandwiched between carbon and hydrogen chains. Those are ethers. An example of this would be this structure. We take a carbon chain and we replace the R. If I'm trying to identify what family does this functional group belong to, I'm looking for an oxygen with these 2 R groups on either side of it. That is the only family it could be a part of, is the ethers. All right, amines are our next family. And again, I'm going to use an R for my basic structure. We have a carbon chain of any length attached to a nitrogen. Remember that nitrogens have 2 lone pairs, and this could be attached to 2 hydrogens or any number of other groups. So this could be attached to an R group or a hydrogen and another R group or a hydrogen. This can get a little confusing at first, so let's keep it simple for our actual example. Say we have a 1-carbon amine. Okay, if it's only attached to 1 R group, then we're going to complete the octet by adding 2 H's to it. If this is overwhelming and you're not quite hanging with me yet, you're watching the podcast, you have this to go back and reference. We are going to go over each of these families as an individual chapter. You will get plenty of practice with it. So don't be scared. All right, finally, thiols. Thiols have an SH, also known as a sulfahydryl. So our general structure is an R group. Again, it's a carbon of any length attached to this sulfahydryl. An actual example, let's use a 1-carbon. Okay, again, going back, the presence of this SH or sulfahydryl tells me we have a thiol. The presence of this nitrogen atom tells me that we have an amine. So as you're looking through structures, and you'll get practice on this on the 4th part of this podcast series, anytime you see those, you can say this has an amine in it, this has a thiol, or this has an alcohol.